Look at these figures. L and M are two lines. What is N? N is also a line which cuts L and M. What do you call such a line? Transversal. Line L N is a transversal of L and M. Transversal. When line N intersects L and M, we get how many angles are there formed? Angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, angle 8. There are 8 angles formed by the intersection of transversal and of L and M. Hence. And each of these angles has a specific name, particular name. Angle 1, angle 2, angle 7 and angle 8 are exterior angles. Angle 1, angle 2, angle 7, angle 8, exterior angles. Whereas angle 3, angle 4, angle 6, angle 8, interior angles. Interior angles. Angle 1, angle 2, angle 7, angle 8. 1, 2, 7, 8 exterior angles. Angle 3, angle 4, angle 5, angle 6. Angle 3, angle 4, angle 5, angle 6. Angle 5, angle 6 are interior angles. Interior angles. And angle 1 and angle 3. Angle 1, angle 3. 3. Angle 2 and angle 4. Angle 4. Angle 6 and angle 8. Angle 5 and angle 7 are vertically opposite angles. Vertically opposite angles. Angle 2 and angle 6. Angle 2 and angle 6 are angle 2 and angle 6. Angle 1 and angle 5. Angle 1, angle 5 are corresponding angles. Angle 2 and angle 6, angle 1 and angle 5. Similarly, angle 3 and angle 7 are also corresponding angles. Angle 4 and angle 8 are corresponding angles. What is the relation between angle 3 and angle 5? Alternate interior angles. Interior angles and alternate. They are alternate interior angles. 3 and 5, 4 and 6. 2 and 6 are corresponding angles. 1 and 5 are also corresponding angles. Now, what about the 3 and 6, angles 3 and 6? They lie on the same side. On the same side of the transversal. 3 and 6. Such angles are called co-interior angles. Angles lie on the same side of the transversal. Co-interior angles or allied angles. Co-interior angles or allied angles or constitutive interior angles. Constitutive interior angles. 3 and 6 co-interior angles. Now, consider this figure. Line What is the relation here between L and M? Here L and M are non-parallel lines. Non-parallel. Here L and M are parallel lines. When parallel lines, two parallel lines are intersected by a transversal N, we get 8 different angles. Say 1, 2, 3, 4, 3, 4, 5, 6, 7, 8. 8 different angles. 1 and 3 vertically opposite angles. 5 and 7 vertically opposite. 6 and 8, 2 and 4. Exterior angles 1, 2, 6, 7, 8. Interior angles 3, 4, 6, 5. 5, 6 are interior angles. Now 2 and 6 corresponding angles. 1 and 5 corresponding angles. 3 and 5 alternate angles. 4 and 6 alternate angles. Then 3 and 7 corresponding angles. 4 and 8 corresponding angles. 3 and 6 angles on the same side of the transversal, co-interior angles. 4 and 5 co-interior angles. And now let us see the properties of these angles when two parallel lines are intersected by a transversal. What are the properties of the angles so formed? Let us see it. We have already learned axiom 6.1, 6.2. And what do you call those axioms together? Linear pair axiom. And we have already seen theorem 6.1. What is that? When two lines are intersected, the vertical angles so formed are equal. Now we are going to see the axiom 6.3. 6.3. 6.3. When two parallel lines are intersected by a transversal, the corresponding angles so formed are equal. Corresponding 6.3 axiom. Axiom 6.3. Corresponding angles are equal. Corresponding angles are equal when two parallel lines when two parallels are intersected by a transversal, the corresponding angles formed are equal. That is, angle 1 equal to angle 5, angle 2 equal to angle 6, angle 2 equal to angle 6, angle 1 and angle 5, angle 2 equal to angle 6. Corresponding angle. This is an axiom. What is an axiom? Or which statements are called axioms? Which we can accept without a proof. Because angle 1 and angle 5 are equal. This slanting of these lines will be same. So the angles formed here, vertical angles are equal. These two angles are equal. These two angles are equal. So we can accept this as an axiom. When two lines are intersected by a transversal, parallel lines are intersected by a transversal, the corresponding angles of formed are equal. Now let us consider axiom 6.4, the converse of this idea. Axiom, converse. Axioms need not require proof, so we accept this statement as such. What can be the converse of this statement? When two corresponding angles, when two lines are intersected by a transversal, the corresponding angles so formed are equal, then the lines are parallel. if the corresponding sides, axial 6.4, if the corresponding angles are equal, if the corresponding angles are equal, then the lines are parallel. Lines are parallel. If the lines are parallel, then the corresponding angles are equal when a transversal intersects them. Then conversely, if the corresponding angles are equal, then the lines are parallel. This is axiom 6.4. Now, theorem 6.2. Theorem 6.1, vertical angles are equal when two lines intersect. Now let us consider theorem 6.2. The alternate angles are equal when two lines are intersected by a transversal. The corresponding angles are equal, and if the corresponding angles are equal, then the lines are parallel. Now, theorem 6.2. If two lines are intersected, if two parallel lines are intersected by a transversal, the alternate angles are equal. Alternate angles are equal. Alternate. In the figure, what are the alternate angles? 3 and 5. 3 and 5 or 4 and 6. How can we prove this? Look at the figure. We want to show that angle 3 equal to angle 5. Angle 3 equal to angle 5. Angle 4 equal to angle 6. Angle 1 and angle 3 are equal. Angle 1 and angle 5 are equal. What is the reason? Angle 1 equal to angle 3. Proof of this can be written as angle in the figure. Angle 1 equal to angle 3. Reason? Vertically opposite angles. Vertically opposite angles. That is theorem 6.1 by theorem 6.1. Theorem 6.1. What is the relation between 1 and 5? They are corresponding angles. They are also equal by axiom 6.4. 6.3 by axiom 6.3. Angle 1 is also equal to angle 5 by 6.3. Now combine these two. Angle 1 equal to angle 3, angle 1 equal to angle 5. So what is the relation between angle 3 and angle 5? Angle 3 equal to angle 5. Therefore, angle 3 equal to angle 5. So corresponding, if two lines are intersected by a transversal, the alternate interior angles are equal in measure. Similarly, angle 4 equal to angle 6. The alternate angles, or simply alternate interior angles, are also called alternate angles simply. Both are correct. Now, by axiom 6.1 and by theorem 6.1 and by axiom 6.3, we can establish theorem 6.2. Now, what can be the converse of it? Converse. It is theorem 6.3. Theorem 6.3. Converse. Theorem 6.3. Theorem 6.3 converse. What is theorem 6.2? When two lines are intersected by a parallel lines are intersected by a transversal, the alternate interior angles of formed are equal. Converse, if the alternate interior angles are equal, then the lines are parallel. If the alternate angles are equal, then the lines are parallel. Then the lines are parallel. This is theorem 6.3. Theorem 6.3. Now, third theorem 6.4. Theorem 6.3. Theorem 6.4. When two lines are intersected, when two parallel lines are intersected by a transversal, the co-interior angles so formed. Co-interior angles so formed are equal. Are supplementary. Co-interior angles are supplementary, not equal. Supplementary. Corresponding angles are equal. Alternate interior angles are equal. Corresponding angles 2 and 6 are equal. 1 and 5 are equal. 3 and 7 are equal. 4 and 8 are equal. And also 3 and 5 are equal. 4 and 6 are equal. Alternate interior angles. Alternate exterior angles are also there. Alternate exterior angles. 3 and 5. 7 and 1. 2 and 8. Alternate exterior angles. And when now theorem 6.4, when two parallel lines are intersected by a transversal, the co-interior angles so formed 3 and 6. Angle 3 plus angle 6 equal to 180. Angle 4 plus angle 5 equal to 180. This is theorem 6.4. Here, what is angle 3 plus angle 6? That is what we require. We know that. How can we prove this result? Angle, we want to prove that angle 3 plus angle 6 equal to 180. Angle 6 equal to 180. What is the relation between angle 2 and angle 6? Angle 2 plus angle 2 and angle 6 are equal. Corresponding angles. Angle 2 and angle 6 are equal. Angle 1 and angle 3 are equal. Angle 1 equal to angle 3. What is angle 1 plus angle 2? Angle 3 plus angle 6. Angle 1 plus angle 1 equal to angle 3. Angle 2 equal to angle 4. And we want to show that angle 3 plus angle 6 equal to 180. Angle 3 plus angle 6 180. Angle 1 equal to angle 3. Angle 2 equal to angle 6. So angle 1 plus angle 2 equal to angle 3 plus angle 6. What is angle 1 plus angle 2? 180. Straight angle 180. So angle 3 plus angle. So angle 2 equal to angle 6. Angle 1 equal to angle 3. Angle 1 plus angle 2 equal to 180. Straight angle. Therefore, angle 3 plus angle 6 equal to 180. Theorem 6.4. Then what is theorem 6.5? Theorem converse of this. If co-interior, when two lines are intersected by a transversal, if the co-interior angles are equal, then the lines are parallel. This is converse of theorem 6.4. Theorem 6.4. When two parallel lines are intersected by transversal, the co-interior angles are formed are supplementary, not equal. Co-interior angles are supplementary. Corresponding angles are equal. Alternate angles are equal, and alternate interior angles are equal, and corresponding angles are also equal, but the co-interior angles are supplementary. Now we can extend this theorem for more than two lines. It is theorem 6.6. Theorem 6.6. 6.6. Three lines. Consider three lines. if two or more lines parallel to the same line, if two or more lines, L, M, N, M is parallel to N, N is parallel to L, then M and N are parallel. If two or more lines are parallel to the same lines, then they are also parallel. For that is, this is theorem 6.6. If N is parallel to L and M is parallel to L, then M is parallel to M. M is parallel to L. The theorem 6.6. If L parallel to M, L parallel to N, then M parallel to N. How can we show this result? See, transversal. When two lines are intersected by L, M, N, P, line P. If two lines are intersected by a transversal, what are the properties of the angles formed? Corresponding angles are equal. Corresponding angles. These two angles are equal. Co-interior angles are supplementary. Co-interior angles are supplementary. Alternate angles are equal. Alternate angles are equal. That is 1, 2, 3, 4, 5, 6, 7, 8. 8. And now we can to prove this result. Angle 1 equal to angle 6. Angle 1 equal to angle 6. Now here we have, with respect to N, we have angle 8, 9, 10, 11, 12. Now consider angle 1 and angle 6. Since L parallel to M, angle 1 equal to angle 6. Angle 1 equal to angle 6. Since L parallel to N, angle 1 equal to angle 1 equal to angle 10. Then what is the relation between angle 6 and angle 10? Angle 1 equal to angle 6, angle 1 equal to angle 10. So angle 6 equal to angle 10. That is, these are the corresponding angles. Angle 6 and angle 10. If the corresponding angles are equal, by the converse of the theorem 6.4, that is by 6.4 the lines are parallel. So M and N are parallel. Or we can consider any other angles also to prove this result. So in general, if two or more lines are parallel to the same line, then all are parallel to one another. This is theorem 6.6. Now read textbook pages 98 to 101. Do and study the examples 4, 5 and 6. Do exercise 6.2 all questions. Thank you.